All right, we are going over 6.2, number 14, and it says perform the indicated operations, divide out all common factors in your answer. So they're just saying simplify it. So when we're subtracting fractions like this or rational expressions, you want to make sure that the denominators are the same, right? So now that these denominators are the same, now I could just subtract off the top and then I'm done. The tricky part here for Miss Johnson's tricky part is going to be this negative. So I'm going to distribute out first and then I'm going to deal with the rest of it. So my denominator is going to look exactly the same, x squared minus 9. And then my numerator is going to be the same on the left-hand side. And then I'm going to distribute out that negative on the right-hand side. Okay. So now all I'm going to do is just simplify and then I'm done. So my denominator stays the same. And then I add like terms. So what's 5x squared minus 9x squared? So that's going to be negative 4x squared. And then what's negative 8x minus 4x? Oh, that didn't show up. That's okay. You can kind of see it. So negative 8x minus 4x is going to be negative 12x. So then it goes negative 12x. And then, so you're kind of done, but you just want to check to make sure that you don't have any common factors. Like in fraction land, you would have to simplify it. So I don't know if there's any common factors until I factor it out. Actually, I do know, but I'm going to pretend I don't know until I factor it out. So what I'm going to do is I'm going to factor the top and the bottom to see if I have any common factors. So I know the bottom factors. This is a perfect square. This is a difference of squares to x plus 3, x minus 3. If you don't know that pattern, get used to that pattern. Whenever you see something squared minus squared, then you could break it up into a difference of squares, right? So it's x plus 3, x minus 3. Same thing goes with this one. I'm going to look for a common factor because this is not a difference of squares. And I see these negatives. So I want to take out a negative. And then I look at 4 and 12. And the common factor there is a 4. So I'm going to pull out a negative 4. And I can also take out an x because both of them have an x. So one more time, I see a negative, so I pull out a negative. I see both of them have 4s, so I take out a 4. I see both of them have an x, so I take it out an x. And then it's almost like you're thinking about anti-distributing or undistributing. I'll use the word undistributing, right? So negative 4x times what gives me x squared? That's x. And then negative 4x times what gives me negative 12x, and then that's plus 3. And then I say, hey, look, do you see anything? And you're like, oh, yeah, I see x plus 3 and x plus 3. The whole thing could be canceled because the whole thing is being multiplied by something, right? You can't cancel this 3 with that 3 because the whole thing isn't being multiplied. See, it's being added. So, but I could take the whole thing because the whole thing is being multiplied by something. So these two equal to 1. So my final answer is negative 4x over x minus 3. And someone says, hey, Ms. Johnson, can you cancel out those x's? And I say, no, because this x is being multiplied, but this x is being subtracted by something. So this is actually the answer. Okay. Any questions on that one? All right, let's move on. Okay. The next problem we're going to do is this problem right here, which is this problem. And the difference between this problem and the problem that we just did up here, right, is that this one came to us with a common denominator, right? It came to us with a common denominator, meaning these two numbers on the denominator were the same. That's not how this problem number 18 is coming to us. It's different. So the way I'm going to fix this is I am going to make it a common denominator. Okay, so the very first thing that I notice is that they kind of have something in common, but something feels a little funny about it. So I'm going to start by just factoring out the denominators and seeing if there's any common stuff there. So the first thing I do is I notice that both of them have a 4, so I undistribute, so I get 4 parentheses x minus 3. And I'm like, hey, this is 3 minus x. And then this is something that you're going to learn, but is x minus 3 the same as 3 minus x? Is x minus 3 the same as 3 minus x? And the answer is no. No, it is not the same. Ms. Johnson, why is it not the same? It's not the same because x comes first here and x comes last there. And when we subtract, it's not commutative. Meaning I can't say 10 minus 3 is the same as 3 minus 10. So the way I'm going to fix this is I'm going to switch these guys' places and see what I get. So I'm going to physically move them. So here I go negative x plus 3. And then I'm like, oh my gosh, these are opposites. So I could deal with opposites because I could just kind of like factor out a negative 1. Does that make sense? So I'm going to factor out a negative 1 here, and I get x minus 3. Ms. Johnson, what do you mean by factor out a negative 1? I mean this, like I took out a negative 1. I took out a negative 1. So negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. So this is a pretty slick trick that mathematicians will use to get this guy to look like this. Okay. And because this is a minus right here, I can take this minus and make it a plus. I could take this minus and make it a plus. Okay, so I'm actually going to do that now. So I'm going to copy this. I get 3 over 4 parentheses x minus 3. I'm going to put plus, and then I get 3 on the top. So this negative and this negative make a positive. So I don't know if you like want to follow these little arrows. These two make a positive. Negative times a negative is positive. Okay, so now I'm going to deal with the common denominator. Are these two the same? And you're like, no. And I'm like, okay, well, what would the least common denominator be? And I'm like, oh, they both have x minus 3. Good. Is he missing anything? You're like, no, he's not missing anything. Is this guy missing something? And you're like, yeah, he's missing a 4, right? I want them to look the same. So the way I handle this is I multiply both by 1, which in this case looks like a 4 over 4. And now my denominator has a 4 and an x minus 3, 4x minus 3, so we're good. So then my answer is going to be equal to my denominator, 4 parentheses x minus 3. And then my numerator is going to be 3 plus 3 times 4, which this is 12. So this is going to be 3 plus 12, which is 15. And they say, okay, can I simplify you? And I'm like, no. Some of you will say, hey, Ms. Johnson, can you simplify that 15 and the 3? Your answer should be no. Why not, Ms. Johnson? Because of that minus. Okay. Very good. Any questions on this? No. Good job.